Good morning, everyone. My name is Timothy Lee Grant, and just as promised, we are back again with sum of squared error. How exciting, right? All right, so here it is. In the last video, we talked about what a model actually is. So we have some mapping between inputs and prediction, right? In this case, it's square foot, which gets mapped right here along our model to, for any input, we are given a corresponding prediction, which in this case is the price. All right, then we have our training data here. Each of these are individual instances. In this case, it's a house, and this house, we are given both the inputs, which in this case is there's just one input, right? And the corresponding output. So we're given both the inputs and the actual value which we will try to learn. So in this case, it's the price. Okay, cool. So what is sum of squared errors? And why do we use that as our metric for error? All right, so let's just go through the name. Sum of squared error. So sum makes it kind of sound like what we're going to do is we're going to add up all of the errors which we see over our data set, which is exactly what we do. So what is the error for this particular point right here? Okay, so we're going to look at this point right there. What is the error of this point given our model? Well, our model says for this input right here, okay, we are going to predict this value, right? For this input, we're predicting this value. But that's off from the actual data set that we were given, our training data, right? Well, how much is it off by? It's off by this much right here, right? This is the error. Here's the actual data. Here is what we predicted it was going to be. So here is the error. All right, well, what about this point? Well, it's between here and here. Here and here, here and here, 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 here. Oh, that one looks like it's almost zero. We did pretty good on that point. Here, 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 here. Okay. So that's the error, and now what we do is we just take each of our data points and sum up the error. But if you notice, our model sometimes, this one, the actual value is higher than what our model predicted. But for this one, the actual value is much lower than what our model predicted. And if we just sum them up, this positive is going to start canceling out this negative, which isn't really what we want to do because we're looking for how much our model, or the training set, deviates from our model. So we want to add up all of the error, regardless of if it's positive or negative. And whenever you want to do this, one of the very nice tricks is that square takes both positive and negative and just gets rid of that negative sign. So what we want to do is we want to sum up. Okay, so let's start writing this in math terms. Sum. We want to take the sum of error, and we want to square the error, right? Okay, well, let's keep making it a little bit more math. Okay, so I guess we'll start with this. So the summation. So how you do it is, I guess we can start saying training data. Okay, so we want to train over all of our training data and sum the error and square it. Okay, well, let's write it a little bit better than that. So how do we say iterate over our training data? How do we put that into actual summation notation? Well, let's say that we have n data points. So what we do is I equals 1. This is our starting value, so I is going to be the variable which we iterate over. Okay? So I starts from 1. It's going to start from the first one, then go second, third, fourth, fifth, sixth, seventh, eighth, all the way up to, in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12, 13, 14, 15, up to 15. So this is another number. Start from 1, go to 15. Okay? Now, error. That's not very technical. Let's get that. What is error? Well, we said it here. Error is this. How do we actually calculate that? Well, for any input, we're given a corresponding output, right? Which is dictated by our equation. Correct? This is our model, okay? So it is the actual minus predicted. Predicted, and then that's squared, right? So actual minus predicted. Okay. Well, what is the actual? Actual is going to be y of I. So now what is y of I? In our training data, we are given a vector for the different inputs, and we are also given a vector for the outputs. So y1, y2, y3, dot, 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 all the way, in this case, up to y15, okay? And then here, so this is, and then this is square foot. Okay, this x1 is going to be that value, so we're going to have some x1 value, then x2 value, dot, 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 up to x15. And so here is our training data, right here, okay? So let's talk about that in relationship to this graph right here. What does this mean? So our training data, we just plotted on this graph, right? So we're given an x1. In this case, this is our x1 right here, and a y1, which is right there, y1, okay? x2 is this training data set, or training data point right there. Has a particular x value and a particular y value, which is the output, okay? And there's 15 of them. So this is x1, and this is x1, this is y1, this is x2 right here, this is y2. So we just kept going through, and we're given these two vectors, and we can just plot them, right? So we're given this. We have this information. Okay, so y of I is going to be the ith actual value, right? We wanted the actual value, and that's here for the first one, here for the second, third, fourth, fifth, right? That's what I mean by iterating. We're iterating over this I variable. So here is the first actual value, here's the second actual value, third actual value, all the way up to the 15th actual value. Great. Okay. Predicted. How do we get the predicted? That's our model, right? And our model, we have some equation for it, correct? Okay, so this is like y equals 1.5x plus 3 something. Okay, so what do? We take this input, we put it into our model, and we get an output. And this will be done through your machine learning program, right? You are going to create a model, and your model is going to have some output. Well, you just put the output right there. Fair enough, right? So in this case, we would have, for predicted, if that's our equation governing the output, we would just have 1.5 x of I, the ith, I erased it, but the ith input corresponding to the ith output, plus 3, and this entire thing is going to be subtracted from the actual output. And that's our equation, okay? So this right here is going to be produced by your model. So you won't actually have to have an actual equation. You just need to be able to get some output, right? Your model will produce an output, and that's what goes here, is output of your model, okay? This right here is given to you. Given. It's a given input. You know how to square, and this is just a for loop. Okay, and this is going to be the sum of squared error. There it is. This is our equation, right? So we just do a for loop, and we take, for each iteration, we go through, and in this case it was 15, but we can generalize it to n, and n in this case means the number of training points, okay? So we just do a for loop from the first training point to the last training point, and in each iteration, we take the actual value, which was given to us, and subtract what our model says the output should be given the input parameter of the associated iteration. So if this is so if you have like 4, and then I, in this particular iteration, I is 3, right? So it starts at 0 or whatever, right? It starts at your first training point, but then iterates over. So if you're at the 4th iteration and you're 1, 2, 3, 4. So this is x4. Okay. So you look at the 4th output, or the actual data which you're given, okay, in your label of the training data. Then you take the 4th input and plug it into your model and get some output, subtract it, then square it, and this will be some value. It'll give you some value, and you just iterate over and keep adding to the sum, maybe a variable called sum, and at the end of your training data, that's your sum of squared errors. That's how you do it. That's how you judge for a linear model how good or bad it is. And then the point is you try to adjust your two parameters, your two weights, right there. You try to adjust it to minimize this sum of squared errors. And now, I was talking about doing this through a for loop. And yes, that's the best way to conceptualize it. But actually, for loops are a little bit slow when you're actually trying to iterate over a large amount of training data. So the way that people actually do it is they take advantage of matrix operations. So in the upcoming videos, I'm going to show you how you actually can compute this value very easily, very quickly, very efficiently using matrix operations, because it's actually kind Kind of cool how you're able to create a linear function with your inputs and then have a weight vector and just multiply them and you get some output. It's actually pretty cool and I'm excited to teach it. So I hope to see you guys then and have a wonderful day.